Welcome to Digital Toolbox. Today we're going to create a door that we can adjust the height and the width and other variables to our door. And we can also adjust the door swings degree. So when we bake this into Rhino and apply it to our model and we create sections, we don't have to recreate the arcs or the door stops and the door frames to create an accurate design development drawing for Rhino. So to begin this definition, I'm just going to copy these sliders and then I'll tell you guys what we need. So I'm just going to copy and paste this into a new definition. We're going to need a slider for the door width in inches, and I have it from the lower limit of 0 to upper limit of 48. And right now I have it at 36. And we also need the door thickness in inches, and I left it from 1 to 3, and right now it's at 1. I have a door height in inches from 0 to 96, and I left it at the ADA height of 80 inches. And then I need the degree of the door, the swing of the door, and I'm going to leave it at 90 degrees from 0 to 180. And then we're going to need the door stops width in inches from 0 to 2 in floating points of 1 decimal, and I have it at 0.5. And then the door stop thickness in inches from 0 to 3 in floating points of 1 decimal, and I have it right now at 2.5. And then the door frames width in inches from 0 to 12, and right now I have it at 8. Door frames thickness from 0 to 3, and right now I have it at 1. And then you guys are going to need a one variable expression for each slider to convert into inches in Rhino, since we usually use feet in the Rhino models. So everything is going to be x over 12 except for the degrees, which is going to be x over 360. And you'll see why we need to divide by 360 as the tutorial goes on. So to create our door frame, we're going to need a box in surface, under primitive, interval box. And to create the x direction, we're going to need a two variable expression. And we're going to need to add a door frame's thickness plus the door width. So the door width is going to be the first slider. So I'm going to add that into x, and the door thickness, which is the last slider, goes into y. Just going to make sure. Door frames width, door frame thickness. So into the expression editor, I'm going to type in x plus open parentheses 2 times y, close parentheses. We're multiplying the door frame's thickness by 2 because we need to add an inch on each side of the door. And then this will go into the x value of the box. And then the height of the box is going to be the door height plus the door thickness. Door frame's thickness. So we're going to need a two variable expression again. The door height is going to be the third slider, which is the third function. Adding the thickness also, so x plus y. Into the expression editor, commit changes, and that will go into the z direction, which is the height of the door, or the door frame, and then y, which is going to be our thickness, and that's just going to go into y. So that's the overall width of the door frame. We need to subtract this box with another box to get the actual frame. So we're going to go to surface, go to primitive, and grab another interval box. This one will be, the z direction will be simply the door height. The y will be the same width of the door frame, and then x will be the door width. So now we need to move the overall width of the door over by 1 inch so that these two boxes are center to each other. So to do that, I'm going to go to Xform, go to Euclidean, go to Move. I'm going to put this box into the geometry, and then we need to move it in the X direction. So go to Vector and grab the X, and then we need to move it in the negative direction of the door frame's thickness. So I'm going to go to logic and grab the one variable expression, and this is going to be negative x. Put that into f, and then put this into the thickness. And I'm going to unpreview this box so you guys can see that now that they're centered from each other. And then I'm going to go to intersect, go to boolean, and grab the solid difference and apply it to the box and move, and then unpreview these. And now we have our door frame. The last thing we need to do is to move this frame forward by several inches. And to do that, or why we need to do that, is because when I close the door here, I want the door to be flush with the frame. And we're going to set the door at the origin of the axes. So to do that, we're going to move this geometry again. So I'm going to grab another move button, and we're going to move it in the y direction. So go to vector and grab the y vector. And then to move it, we're going to take the door width and then subtract it from the door, or the door frame's width, and subtract it from the door thickness. So another two variable expression. Y will go into the door frame's thickness will go into x, and then the door thickness will go into y, and the expression will be y minus x. Commit changes. So now let's move forward, unpreview the difference. So now our door frame is moved forward several inches. So when we set our door, depending on the thickness, it will close within the door frame. So that's how you create the door frame, and continue on so we can create the door stop. And thanks for watching.